Hello, my name is Andrew Thate from Resourcing Tomorrow. Delighted to be joined today by Hannah Lang, who's the team leader for digital solutions at Minesense. Delighted to have you with us today, Hannah.
Yeah, thank you, Andrew. I'm really excited to be here.
For those who don't know much about Minesense, can you give us a quick overview of the company?
Yeah, so Minesense is a technology company out of Vancouver, British Columbia. It actually started as a startup out of UBC, one of the colleges here, and it's transformed into a full-scale company at this point. We have an office in Vancouver. We also have an office in Santiago, Chile, and we service mines predominantly at this point, open pit copper mines throughout North and South America. And we have trials and clients that we're starting to bring on board globally at this point. But what we actually do is we retrofit XRF sensors on the front of shovels of excavators, front end loaders. And so as the shovel is digging, the X-rays are being emitted and are actually giving a reading of the material in the bucket. So every time that the bucket digs in an open pit mine, we actually can predict the grade of material in that bucket and material characteristics such as the hardness or the mineral speciation. And then by the time that that bucket empties into the truck, because we're integrated with the fleet management system, we can actually deliver a material classification such as waste or ore to the fleet management system. And if that's different than what the mine plan was, then that truck gets rerouted in real time. So essentially it's bulk ore sorting, but at the mine face where you have the most variability and the most potential to actually make real changes to the efficiency.
Digging down a little bit sort of deeper, what are the challenges of mine to mill optimization? Why is sort of like, but you can just go into some of the specific like challenges there.
Yeah, so what we're doing now is looking at integrating our data into the entire mining process to create mine to mill optimization, where essentially you're taking those data points. I've mentioned shovel sense. We also have belt sense, which is where we put those same XRF sensors over top of belt. And it's through that integration of data with, advanced process control downstream or the mine planning software that you can really start to use that data to improve the efficiency of processing or the efficiency of mine planning. The real challenge there is you can have this amazing high quality, high resolution data, but unless you're actually using it to make an operational change and to change the way that mines are operating, it's going to go, unused and it's going to become insignificant. And so it's really the challenge is how do we integrate that data into the processes that are already in place to optimize them? And that's something we're just starting to work on now, but we see huge potential for benefits downstream.
And you talk about seeing the potential for huge benefits downstream. What are the typical downstream improvements that a miner would see if they were to take on board Minesense's solutions?
So in one case, we actually did an analysis ourselves where we looked at as you increase the coverage of shovel sense. So if you have more and more shovels in your operation equipped with shovel sense, how does that correlate to recovery improvements downstream? And what we found is that as we increased the coverage of shovel sense, because at this particular client site, we went from only having a couple shovels with shovel sense to their entire fleet. We saw that on shifts where they had greater than 50-60% of the mill feed being delivered by trucks that were fed by shovel sense, they saw improvements of up to 5% recovery of those shifts compared to the shifts where they were feeding less than 20%. And so that's actually taking a look at the mine's data, their downstream recovery of every day, and correlating it to when they were using our system. And so that's a pretty major improvement in recovery for simply just letting the system run. And then it's with our digital solutions and the adaptation of advanced learning models to predict more than just grade that we can further improve recovery downstream by predicting more than the grade and understanding the variability and the characteristics that make up the ore that's feeding the mill.
And can you give a specific client that you've worked with where you've sort of like managed to bring this all together in a successful outcome?
Yep, we've been working, one of our clients that is actually local in BC, Copper Mountain in Princeton, BC, they've been using our technology for a number of years now. And one of the outcomes that we've had with them is we've actually installed belt sense in the grinding circuit. And then we started to work on these advanced machine learning models with Sense. And so one of the challenges that they have with their ore feed is that copper is housed in different minerals. So you can have chalcopyrite, you can have bornite, and those minerals behave differently when they reach the flotation tanks. And so you actually need to process them differently, add slightly different reagents to maximize recovery. And they knew of this challenge, but at the time they were not really directly tracking exactly which trucks had which mineral speciation. And so we actually took their block model classifications and we ran it through a machine learning model with our XRF spectra, where multiple peaks were actually used to create a relationship between what we see and the mineral speciation. And so we were able to then predict both on Sense and on Sense, because it's the same sensor, what the mineral composition was and whether the ore was dominated by chalcopyrite or bornite. And then those readings can actually be fed directly into an advanced process control system or a smart reagent addition system and be able to make sure that the material is being processed correctly. So I think that's an example that we're quite proud of being able to do something most people wouldn't use XRF in this way. You're simply looking at an individual peak, correlating it to a grade, but really there's a lot of information to unpack from a spectra and relationships between different elements that when you can apply machine learning to that, you can really produce some pretty impactful prediction models.
Lots of other sort of similar solutions out there, lots of other XRF solutions out there. What makes Minesense stand out from the rest of the crowd?
Minesense is the only or one of the only companies that is actually putting lab quality sensors on the front of a shovel. And when we started out, people thought it was, a crazy idea because you have issues with sensors like this breaking even when they're in the perfect condition. And so our real challenge has been taking this very, very sensitive sensor and figuring out how to equip it to be able to be, bombarded by rocks. But once we were able to do that, I think it gave us a competitive edge because now we're able to measure every single bucket and see the ore body in a visibility that has never before been possible. We also combine our readings with a location. So we have a high precision GPS that's also on the shovels. And so you can literally visualize the deposit as it's being dug out. And that data at that resolution, we've never seen before. Usually you're measuring pre-blast material or you're measuring at least maybe trucks or downstream on the belt. But to actually see bucket by bucket as you're digging through your ore body is a pretty amazing data set. And there's a lot of competitive advantages, I think, to going through the hassle of equipping these lab sensors onto shovels, but being able to see the data at that resolution.
All the best ideas start off as crazy ideas. I think that was something I would definitely say. One final question. What's on the horizon for Minesense for 2024? Any sort of new refinements to either Sense or Sense or any new products coming out?
Yeah, in addition to, just continuing to expand our client base, working in different commodities. So we started in open pit copper. We're now looking at working with iron, nickel, zinc, lead deposits, a whole suite of commodities. We also have started trialing our system on underground shovels. So that really opens us up to being able to work through block caves and a whole suite of different processes there. And in addition, we're starting to develop new sensors too to put on our shovels. So we started with looking at MSI and HSI, so multispectral and hyperspectral imaging cameras that should allow us to detect oxides and detect clays. So we're looking at additional sensors, additional places we can install them, and really bringing the entire kind of mine to mill picture in place where we can use this data not only to reroute trucks, but also to optimize the entire mine to mill process.
Well, we were delighted to have Minesense resourcing tomorrow and delighted to go and catch up with you again today. That was Hannah Lang, team leader for digital solutions for Minesense. Thank you very much for your time.
Yep, thank you, Andrew.
Resourcing tomorrow, accelerating the energy transition. 100+ countries represented. And together with government representatives, mining and energy professionals, ESG experts, financial and professional services, industry associations, investors, and consultants, Resourcing Tomorrow will address critical mineral supply, the energy transition, environmental resilience, the circular economy, ESG, our future workforce, AI automation and machine learning, digitalization, mineral processing and plant optimization, exploration and development projects. Have your say in the future of our industry. Join us for Resourcing Tomorrow from 28 to 30 November 2023. Register today